Hello, today we will be talking about extant Agnatha. In the previous lecture, we introduced the Agnatha, the jawless fishes. We started by looking at where they fit into kind of the groups of animals. We looked at how they are chordates and how they are vertebrates. And then we took the Agnathas a little bit farther, looked at them in detail, and looked at the two major extinct groups of jawless fishes, our conodonts and our ostracoderms. Today we're going to come back to the idea of the Agnatha, and we're going to look at our living representatives, our two extant groups, our hagfishes and our lampreys. So these are our two groups. We have our hagfish, kind of longish and purplish pink colored, and we have our lamprey. They're both elongate fishes, kind of have that eel-like body shape, but we'll look at how they're a little different as well. So the hagfish, this is class Myxini, superclass Myxinomorpha, order Myxiniformes. Are you noticing a pattern there? Myxina, that's mucus. We'll see that as a root word for all of the different ways we have of identifying our hagfishes. Our hagfish are marine, temperate. They're found at depths 25 to 600 meters, 40 so species give or take. They are fairly simple. They have one semicircular canal, one olfactory capsule. And when we look at them, we see that they don't have a lot. Some people don't even consider them true vertebrates because they lack vertebrae, they lack bone. They don't have a lateral line system. We have that nice eel-like body, rudimentary eyes, simple kidneys, gill openings that run down the side. They're a fairly straightforward fish. When we look at their mouth, we see some specific differences here. We have 6 tentacles out to search for that food. Horny plates within the mouth with tooth-like structures and plates on either side of a protrusible tongue. So even though they don't have a mouth that can open and close, they have mouth parts that they can protrude and push out, and they can use those to grasp onto food bits. How do you eat? How do you chew? How do you get a piece of food if you don't actually have teeth or a jaw? Well, you rasp on with those little mouth parts that you have, and then you feed by passing a knot along your body to rip off a chunk of flesh. And this is easy to do if you have the ability to tie yourself in knots. You can see here that hagfish is able to twist its body around. And then in the cartoon here, you can see how it can actually pass a knot, right? Tie itself there, pass the knot along its body. This allows it to rip off a chunk of flesh. They're usually feeding on dead and decaying animals. They're scavengers, so it's pretty soft flesh that they're feeding on. They're just going to rip off a piece that they can then swallow. We'll start by looking here at a little video that shows these hagfish in action.
This is the freshly dead carcass of a 30-ton grey whale. It's resting on the seafloor a mile down. It's only been on the bottom for 6 weeks, but already it has attracted hundreds of hagfish. These ancient scavengers are nearly always the first to discover a fallen body and are attracted from miles around. They lack jaws and rasp at the flesh with 2 rows of horny teeth on either side of their sucker-like mouths.
So that kind of gives you an idea of the hagfish in motion and how they feed. And we have one more picture. If you watch carefully over on this side towards the end, they talk about the knot on the body and how it passes through, but it's kind of a trick to see it. We'll see if how well it shows up.
Hagfish have a skeleton of cartilage and are so flexible that they can tie themselves into knots and so get a better grip on the flesh they feed on.
See that knot over here at the very end? It's kind of interesting the way they can do that, the way they're adapted for their environment perfectly. So one of the other characters we have to talk about when we talk about hagfish is the mucus that they produce. So this is kind of unique to hagfish. If you touch one, if you play with one in a vat of water, it will produce this mucus. And basically they have these glands that secrete the mucus and these proteinaceous threads. And the threads are kind of what's important. They're about 1 micron wide, so they're thinner than human hair. They're about 6 inches long. And they straighten in the seawater and hold the mucus against the body. And the thought is that this kind of clogs the gills of a predator and maybe keeps that predator from attacking you, because now the predator is more worried about breathing than it is about eating the slimy hagfish. So the thought is it's probably a predator deterrent, but it has some people thinking about it as a potential for a clothing option. It's very thin, right? 1 micron wide, nice and thin. It's almost as strong as spider silk. So if there's some way that it could be harvested, It could potentially be used in place of things like nylon, which is actually petroleum-based, and kind of be a more natural alternative, though they would need to work on the marketing because hagfish mucus slime thread clothing probably isn't going to sell very well. We do know a little bit about hagfish, not really very much, given the numbers that we saw on that previous slide, but they do live at depth, and that does make it a little difficult to figure out a lot about them. They appear to be, most of the populations anyway, appear to be female biased, and some are hermaphroditic, and we don't know what that means. If that means they switch at some point during their life, if there's some kind of environmental cue, and that suggests if you're going to switch during your life that you are a long-lived species. We have no idea how they mate, but we do know what their eggs look like. We know they're big. They're bigger than a centimeter. They're oval, yolky, and they have this tough, clear covering on the outside of them. But there does not appear to be any larval stage. They appear to hatch as just mini, cute little baby, well, maybe not cute, but little tiny baby hagfish, just the same. How do we interact with them? I just got done telling you we don't know that much about them, so do we really interact very much? And the answer is we do. We harvest them. We don't really know their numbers. We don't know what effect we're having on them as a fisheries, as a species. And we saw their role as scavengers on the previous slide, right? That they're feeding on that carcass, but they're also a big food supply, food source for other animals that live in the marine environment. But we do harvest them, and we take their skin and we turn it into things like wallets and boots and purses. But we don't market it as hagfish skin items. We call them eel skin. So if you buy an eel skin wallet, it's most likely actually come from a hagfish. Hagfish name doesn't sell very well. And in some places in Korea, they keep the hagfish in these tanks inshore, and they'll stimulate them on purpose, irritate them to produce the slime, and then they'll collect the slime, and they'll use that in cooking. And it's similar to egg whites, like kind of as a thickener. So it does have a market that way. Again, we have no real sense of what's going on with the natural populations, but we do harvest them for our own use, at least so far. Before we get into our second living jawless fish, the lamprey, we'll throw a weekly review question out there. Remember back to those other extinct jawless fishes we were talking about, the ostracoderms? Are they considered to be monophyletic? So here I'm testing two things. Do you have any idea what an ostracoderm is? And do you remember what monophyletic means? Check back at your notes, add this to your list of questions for this week, and send it to me in an email at the end of the week. On to our second living jawless fish. These are the Petromyzontiformes. These are our lampreys. And now we've got about 40 species, and they range in size from little, about 10 centimeters, up to about a meter long. Many of them are anadromous, where they spend their time in large bodies of water and then return to rivers in order to breed. We see that isocircle tail in adults, right? Kind of goes around there. You can see it better here on this guy like that. You've got that nice little dorsal fin. 1 or 2 dorsal fins in those. That's different than what we saw in the hagfish, right? The hagfish have just that kind of single continuous caudal fin that they have. No paired fins in these guys either, same as we saw in the hagfishes. Just a long eel-like body. Those nice distinct gill openings there, which help. We do see that we have now well-developed eyes, and that's different again from what we saw in the hagfish. So we lump them together as jawless fishes, but that doesn't mean they're the same. So we've got those nice big eyeballs here, no mucus, up to 2 semicircular canals. That's what we see in ostracoderms and gnathostomes. Hagfishes just have 1. No barbels on this mouth at all. And we've talked a little bit about how their different systems work when we're working our way through them, how the parasympathetic nervous system innervates the heart in this one, but it doesn't in the hagfish. We've got kidneys and chloride transporting cells in the gills, things that we don't see in the hagfish. And that may just be that the lamprey lives in different habitats. The hagfish lives in a pretty stable habitat, so it doesn't need to worry about that. It keeps itself pretty isoosmotic with roughly the same concentration as seawater. Feeding. Oh, we do have a different mouth on this guy. We don't have barbels, but look at that mouth part we have there. Most of the adults are parasitic. Some of the small species are not parasitic. The adults don't feed. They just kind of return to the streams and breed at that point. They're going to attach to their host by suction. They're going to rasp the skin. They've got that oral hood in here, the protrusibles covered tongue-like structure. Again, tongue-like and spiny, but these are not true tongues, nor are they true teeth. We do not have a jaw here. And you can see how they would attach themselves onto the fish here. The diet is body fluids. So they have a pretty simple digestive tract, right? They're basically just digesting blood. In general, they're not trying to kill the host, right? That's a good parasite doesn't kill the host, they're going to weaken it. But if you have a fish that is being fed on by multiples of these lamprey, you're going to definitely weaken it and probably lead to the death of the fish. We talked about the K condition factor. The fish that have had a lamprey attached to them would have a very low K value at that point. And you too, if you are crazy enough, like the river monster guy here, to go swimming in the water, and your skin temperature drops, you might get a lamprey to attach. You can go on Google or YouTube and you can find all sorts of crazy people who think this is a fun thing to do. But basically, if you're warm, the lamprey probably isn't going to attach to you. It's looking for something cold like the fish would be. And then yes, you too could have a lamprey attach. I don't know why, but you could. Life cycle of a lamprey. So this is the parasitic one. This is the one that we kind of interact with the most. We'll start here with the spawning adults. Okay, they make their nest, and this is how they get their name, is their mouth rock. The adults will sucker themselves onto large rocks and thrash about, breaking up rocks and crashing other rocks. And basically what they're doing is they're moving the debris downstream, so it makes this kind of like nest-like curve. And the idea is it's going to protect the developing eggs from the water current, but that the rocks add enough turbulence so that you get oxygen being brought in and enough flow to get waste matter out. And then I think the female attaches and the male attaches to her, and they spawn on the rocks. They spawn and the young get carried down. Then the adults die. The young hatch, and then we have a larval stage. And this is kind of interesting. The larval will hatch after a couple weeks, and 7 to 10 days after they hatch, they can move down and they find a place where they want to be, and they burrow into the mud. And then they look like this. They're ammocetes. And ammocetes look so different that for a long time they were considered a different species. They didn't even realize that this is what the baby, the juvenile lamprey looked like. So they have this distinct long larval stage. And this developing stage, these ammocetes, remember when we talked about senses and navigation, the odor that they produce may actually attract adults when they're ready to spawn, because they know if there's young there that this is a good place for them to lay their eggs, because it's obviously good for there to be young. So they're in this larval stage for a long period of time, depends on the species, 3 years up to 15 years. And then they're going to transform from the ammocetes into an adult, and they're going to move to a larger body of water. In this case, we're talking about a lake. There'll be a parasitic stage in this lake. They may be there for a year or 2 years, feeding on the adult fishes, and then they're going to return to the river and they're going to spawn and die. All right, so it's kind of a straightforward life cycle, but we see this distinct larval stage here in the middle, at the beginning, a distinct long larval stage, transform, parasitic stage, and then spawn and start it all over again. Reproduction for lamprey, we know a bit more about lamprey. They're anadromous, like we said, live as adults in large lakes or in oceans, and then migrate to smaller river bodies, rivers and streams, in which to breed. The females now are going to lay hundreds to thousands of small eggs. These are tiny eggs, about 1 millimeter in size, with no protective covering in that nest that we talked about. And we mentioned how they build their nest, and then the female does attach to the rock, releases her eggs, the male wraps around the female and fertilizes, releases his sperm as the eggs are released. And then the adults die, the eggs hatch, and the young are on their own. How do we interact with lampreys? Well, we do. The populations have invaded places where they're not naturally found. We've moved fish around, we've connected water bodies that aren't normally connected. And they've invaded the Great Lakes in particular, and there they threaten the sports fisheries. So we have all sorts of mechanisms we use to try to reduce their numbers. We're very aware of how many lamprey there are, and we're doing our best to get rid of them. So we have lampricides, which sounds like a wonderful crime to commit. You're guilty of lampricide. You killed the lamprey. Electrical barriers, mechanical wares, things that can stop the lamprey from moving but won't bother the fish. And this has helped to reduce the populations. Although in some places they just like to eat them. It's considered a delicacy. Rumor has it that King Henry I in the year 1135 gorged himself to death on lamprey. So you could have them like this, which I think would really turn people off, especially if you got the piece with the sucker mouth on the end. I don't know, maybe that's the prize piece to get. And then over here we have the Latvian lamprey, cooked in lavender juice and served with a mustard cream. I don't know if that would be enough to get me to try it, maybe, but it's kind of interesting. I guess it just depends on your culture. So we do use lamprey in a couple different ways. We're trying to get rid of them, but we do also eat them in some places. So that was our look at our living Agnatha, our extant jawless fishes, our hagfishes, and our lampreys. As always, as you work your way through today's lecture, please let me know if you have any questions. Thank you.